So the presentation can be seen, right?
Yes, perfect.
Okay, very good. Yeah, thanks also for invitation or giving me the possibility to talk here, and also thanks to the speakers before. Very, very interesting. Compared to the talks we have heard before, we are not talking about analysis in liquid phase, but in gas phase. And our main topic is also process optimization, in this case also bioprocessing. Just to give you an idea where we are, as mentioned before from Annika, we are not located in Berlin. You see Berlin is on the right side here. Let me point my laser pointer. We are on the opposite of Germany in the Ruhr area. And furthermore, maybe people are more well known to the Schalke 04. Unfortunately, not in the Premier League at the moment. BlueSens itself is founded in Herten, Westfalen. And this was one of the biggest coal mining area, Europe's biggest coal mining area until 2000 roughly. We have 4 coal mines here, and during our settle up here, we started to bring new workplaces with new technology to this region. In addition to that, and that is the good thing at the moment, we have nice areas to go. We have 2 castles, and all the former coal mining areas are renewed, and everything is very green right now. So nice area to visit, although Berlin is nice too. We manufacture in Herten. So that's where we build up all our equipments, where the development is done. So it's a headquarter. Since 2015, we do have a subsidiary in the US and Canada. This is based in Wooddale. It's a town called, it's the backdoor of O'Hare Airport, Chicago. In addition, we do have a huge network of distributors all around the world. And finally, we do high quality gas sensor for fermentation processes. And we have a in-house development bioprocess software, BlueVIS, that can do a lot of things, what I'm going to tell you in the with the coming slides here. In addition to the distribution network work, you can find our analyzer in the top 10 of the global players of fermentation manufacturing. So sometimes you won't see it's a BlueSens, but it's an OEM product. But it's the fermentation system itself is equipped with it. So when you do a fermentation, what do we have? What do we get? In this case, we have a, say, let's call fermenter or vessel, whatever it is, however it looks like, which scale doesn't matter. You basically have mostly some kind of pressure in. You do have a pH, temp, PO, or dissolved oxygen measurement inside. We do have a stirrer to get a decent mixing or even aeration in there. So it means we also add some kind of gas. Could be just simple air, but also could be gas mixtures. We are not always talking about aerobic processes where we measure or introduce oxygen, but also anaerobic processes where other gases like CO2 or methane are produced or integrated to, on the other hand, produce other products that are valuable chemical components, for example. We do have a flow rate. This could be a liquid that is added to the fermenter. And mostly in the case, we are talking about a feed of a substrate, of a sugar source, for example, but also pH control or antifoam needs to be added to a running fermenter. On the other hand, we do have an outlet of a fermenter and where we can get the gases out of the system. These gases we do measure with our products, and we are not going to show you a lot of products here. Most of you should know them already, but this can be also dealt in one-to-one meetings later. So the icons that you can see here is, for example, blue 1 Bloom1, BlueVerry, and our famous mushroom type sensors from the past, from the beginning, means 23 years ago. These data that we have here lead into some kind of a crowd of data. And now the question is, what can we do with this data, and what does it help us, or in this case, a customer, to produce, to optimize this process? So with this wide range of data, and let's focus on O2, CO2, for example, and the measurement with our gas analyzer, we try to use it somehow. So because the poor concentration of oxygen and CO2 is helpful, but mostly this does not really lead into process optimization, as they are very specific. So what we do is we biologize our data, and therefore we need some additional information. In this case, we do need the total liquid in the fermenter. We do need to know the mass flow of the gas, and we need the mass flow of incoming, say, substrates, plus finally water that is added or is leaving the bioreactor. With all this data, we finally can get oxygen uptake rate, carbon dioxide emission rate, and the respiratory quotient. And these data we call biological data, because these are correlated to the process and finally to the metabolism of the organism we are looking on. So finally, with this mentioned values, there are a few more things we can calculate from them, like a biomass and a growth rate. This is not, this is not a direct value. Mostly you need to have some more data, and today we can do that with soft sensing. Just to give you an idea, when we talk about oxygen uptake rate, where is it coming from? Most of you will know that a gas bubble that contains oxygen and that enters the liquid or is in the liquid phase of a bioreactor loses somehow the oxygen on the way to the top, and the transfer rate from the gas into the liquid phase is known as oxygen transfer rate, and that is what we physically measure. And from there, with an assumption, we calculate or we assume that the oxygen uptake rate of the cell is basically the same. The only assumption that we have here is that finally there's no accumulation of oxygen in the liquid phase of the bioreactor. The respiratory quotient, in this case, for example, shown for yeast culture, is also very helpful. So if you have a glucose plus oxygen converted, then you have basically a respiratory quotient of 1. So this is, say, a metabolism that is for growth rate of yeast. On the other hand, if you, for example, have a respiratory quotient that is above 1 or higher than 1, then you mostly have something that produces more CO2. And in this case, for the yeast culture, ethanol is produced. So this happens if there is not enough oxygen and or too much sugar in the system. On the other hand, we also can observe that ethanol can be a substrate or carbon source for the yeast. And in this case, the respiratory quotient is below 1. And you can immediately see that ethanol is consumed. So finally, what can we say? That the off-gas analysis is a kind of multi-tool, because we can cover multiple applications and we are not depending on anything that is in the liquid phase, no bubbles, no turbidity, no other things, color, everything that does not really harm or the result here. So it means the respiratory quotient can be used for the control of production. we can also do biomass estimation with it. For, say, well-known system, we can also do real biomass calculation. We can reduce byproducts and the need of substrate. This is basically more in the world of cell culture, where we can reduce the lactate production by control of the feed of glucose. We can do a feed control by the growth rate. And finally, that is also very helpful. We can do a batch end detection. So it means we know where, for example, the next step can be started. So the feed phase. So now think about what can happen when we have a software which is, say, basically very modular and easy to use. That allows us to use mass and soft sensors without any programming background. So you don't need any coding expertise. And finally, it also enables you to use old new devices independent of the manufacturer or even different brands. So this software is available and it's called BlueVIS. We invented that because we have the same problem. We do have so many different brands of sensors that we need to use. And yeah, there's no one software piece that was able to give us this data. And that's the reason why we have the software. So different type of sensors can be connected. And here it doesn't matter if it's a digital or an analog signal. We can convert analog signals to digital. But we have to mention that we do not have a control tower for this. So this is really a computer software. With this data and additional data from actuators like pumps, valves, mass flow controller, steerer, we can then finally start to control a process and optimize by doing adjustments. The logging is mandatory here. So it's basically a very, say clean software. We do not have many buttons, as you can see from here. So that is a quick overview on the left side where you just see the values or some values that are used or shown for one fermenter. And on the other hand, this is a configuration, that's all. So we can monitor several processes in parallel here. Yeah, it is totally easy to connect sensors and actuators. We do have some templates available for digital probes that for example, have a Modbus communication. And here it does not matter which manufacturer it is. We can do the analog connections too with some small gadgets here. And I think one of the biggest gadgets that we have is that we have an integrated OPC server. So it means from our side, the software can deliver data to other software without any additional tools, except the software license on the other side. The calculation for carbon dioxide emission rate, oxygen uptake rate, respiratory quotient are already in there. So that are preset soft sensors. And the same is valid for PAD controller. And for people who wants to run a recipe, we have a sequence controller that also can be used here. The graph interface, as we call it, is basically also very clean. You can design the graph on your own, and for this reason, you can focus on the main aspects here. So the process to create a soft sensor, maybe just to explain what a soft sensor is, it is mostly a piece of a hardware sensor that gives a signal. And if you add some calculation or combine, for example, different signals from different hardware sensors, then you have a soft sensor. And this can be used in BlueVIS, and therefore you get more details on the process by additional calculation. And the good news is you do not have to do that later in Excel. or in other software, you can do it here online, and means the data are available online. So what we do here in with the software, by the way, we do have our own lab. So we have the calculation of the rates. We use PAD controllers to, for example, to pH control or the dissolved oxygen control, but also exponential feeding or simple signal smoothing can be very helpful sometimes. To have a soft sensor in action, this is nothing we can do in go in detail, but the curve that you can see is basically just to show that we can create any signal in here that can be used for calculation, but also for control. As a very simple soft sensor, just to not overuse the time here. This is, for example, a sensor. We call it sample to fix a value. Why is that important? For example, here in the variable ABC, you see we have a control sequence that is right now 0, and is to start a pump, basically. And as soon as the sequence starts, it changes from 1 to 0. In this case, you can see here we have a pretty simple if case here. If this variable A switches to A, then the value B is taken, and that's it. So that means this value is just taken, that we know, okay, this is a start value, and we save this value for later, for example, delta calculation. Or when we, for example, do carbon balance calculations, then we do need to know when we add something. So this is a very, very simple tool, and this mass sensor basically can be used for any kind of formula. So for this way, we do have a very powerful tool here without any programming. Yeah, just to summarize this software, we can connect sensors, actuators, probes from us, also our devices, but also different brands. It can log, so we can log all data, but control and visualize processes in parallel. You do benefit from automated calculations. We can create soft sensors, mass sensors without any programming skills. And by basically, you just have the software. Every sensor actuator is connected with an USB port to the computer. So it means we do not need any additional hardware tower that also costs money and needs a lot of space. So why we do tell you all this? Number one, our slogan is "We love science." That means we like to enable scientists to use easy things, and in this case, we hope that you can use BlueVIS plus equipment very often, very intensive. But we know that we don't know everything. So for here, we are very happy to receive hints, application questions. Can I do this? Can I do this? How can I do that? We do have the bioprocess experts in-house, so we can help you on your process to optimize it. We can also, this is for all the other vendors, when you have equipment that have a digital output and you think maybe an additional software can do additional calculations, feel free to reach us and give us, for example, some more information on your digital outputs. Maybe it's not in, maybe it's not so easy, but we are very happy to improve our software and integrate also other kind of protocols. So that means we are always looking for collaboration. We are also interested in doing projects. Sure, we are hardware manufacturer, so this is where we come from. So we are good in that, to develop electronics, mechanics, and so on. So if you have a project where you need some of this expertise, please feel free to reach us. And thank you for listening, and I'm open for questions.